Assalamualaikum warahmatullahi wabarakatuh. Have a good day. We're from Group 6. We'll present about sieving analysis experiment. First, I will introduce our team. My name is Fatih Gabra. And next, Umar Siddiq, Muhammad Hakimi, Muhammad Imran, and then Fauzan. We will start about talking about how analysis sieving works. First, first step, we can obtain a soil sample about 500 gram and determine its mass. But we have to make sure the soil sample itself have to be in the dry state. If not, you can dry it itself using oven or something else. Second step, we can stack the sieves so that those with larger openings or the larger diameters will place lower, or which means in the down layer, and then for the smaller openings or the smaller diameter on upper layer. The third step is place a pan under the last sieve to collect the portion of soil passing through it while using the sieve machine. Next, my friends will continue on the fourth step.
And the next step is make sure the sieve are clean. If soil particles are stuck in the openings, you can use a brush to poke them out. And the next is wet the pan and all of the sieve separately. And this data need to be take to make a result later. And the next one is pour the soil from above into the stack of sieve and place the cover on it. Put the stack in the sieve shaker, fit the clamps and set a timer around 10 to 15 minutes and start the shaker. And the last one is when time's up, stop the sieve shaker and measure the mass of each sieve and retain soil. So the grain size analysis test is performed to determine the percentage of each size of grain that is contained within a soil sample, and the result of the test can be used to produce the grain size distribution curve. This information is used to classify the soil and to predict its behavior. Okay, that's all from me, and I would like to pass to Muhammad Umar Siddiq.
Okay, thank you. So, for my part, I will discuss about the result analysis. So the first one is after we get the result from the experiment, we will prepare all the data that we get from the experiment into one experimental data sheet, which have these subjects such as percentage retain, cumulative percent retain, percent final, and all this data was calculated from our sieve weight and sieve with the samples and after we have done the sieving. All right. So after we have done this calculation inside this table, then we can move to the second step in analyzing, which is plotting the graph. So when we're plotting the graph, we just plot the graph of percent final by weight against particle size to continue with our calculation in getting our desired result. So from the graph itself, we can determine the D10, D30, and D60, which is the 10th percent and 30th percent and 60th percent of value of particle size from the graph. And then after that, we'll move to calculation by using the values that we have got before from D10, D30, and D60 by using the formula as shown to find the coefficient of curvature and the coefficient of unconformity uh, by using this formula from which we got from above. And after that, since we got the value of CC and CU, we can then determine whether the sand or particle is well graded or poor graded. So is coefficient of curvature CC is a value that can be used to identify a poorly graded soil. So if the CC value is between 1 and 3, then uh, it is poor graded, and Cu is also greater than 4 for gravels and 6 for sands. So therefore, referring to the value that we got from our experiment that we done ourselves, it can be concluded that the particle size for the sample in this experiment is poorly graded based on the Cu and Cc value that we got. Next, I'll pass to my friend Mohammed Hakimi.
Hello. On my part, I will discuss about the application of sieving analysis in petroleum industry.
Okay, there is a few application of sieving analysis in petroleum industry, such as reservoir characterization, drilling fluid analysis, completion design, enhanced oil recovery, and production operations. As for characterization, sieving analysis help to understand the size distribution of sediment particles and its impact on reservoir rock porosity and permeability. As for the drilling fluid analysis, sieving analysis help to determine the size of solid particles present in drilling mud, which can affect the drilling process and wellbore stability. For the completion design, sieving analysis help to evaluate the size of sand particles in produced water, which can cause erosion and damage to completion hardware. So from me, I will pass it to Sheikh Fauzan.
Right. So right now, the civil analysis can help in several application, which is the first is enhanced oil recovery. As what we learned before, we have three type of recovery, which is primary recovery, secondary recovery, and EOR, or we call it as enhanced oil recovery, or I would say tertiary recovery, right? So to analyze the size distribution of propane particles used in hydraulic fracturing and assess its effectiveness in increasing well productivity. And lastly, production operations to monitor the size of solids in produced fluids and to prevent blockage and corrosion in production equipment. So overall, sieving analysis provides valuable information for various petroleum engineering applications, helping to optimize process, minimize operational issues, and enhance overall production efficiency. So that's all from us today. Thank you for listening and see you.